This is 2007 Calculus BC FRQ number 3, the polar problem. If you look at this problem, given the circle R1 equals 2 and R2 equals 3 plus 2 cosine theta, the intersection 2 power 3, 4 power 3. Find the shaded area, part A. If you look at the shaded region, this is 2 power 3 and this is 4 power 3. So if you connect this to the origin, this divided the whole shaded region into two parts, part from the circle and part from R2. So the area from the circle from 2 power 3 and 4 power 3, which is 1/3 of the circle. So the shaded area will be 2/3 of the circle, which is pi times r squared, plus 1/2 integration from, you can call it theta 1 or theta 2, or you can directly write this R2, 3 plus cosine theta squared d theta. You can plug this into your calculator, and the answer is 10.37. Part B. The particle moving with zero velocity along the polar curve given by this is the position at time t. Given dr over dt equals dr over d theta, find the value of dr over dt at this point. So dr over dt at t equals theta equals power 3 based on the given condition equals dr over d theta at this point. You can directly plot this into your graphing calculator and plug it in, give us negative 1.732. What we can say about the motion of the particle, because dr over dt is negative, that means r decreases as t increases. So that means as t keeps going, r is becoming smaller and smaller. So the particle is getting closer to the origin. Part C. For the particle described in part B, given dr over dt equals dr over d theta, find the value. So dr over dt, same thing, dr over d theta at theta equals power 3. However, we know y equals r times sine of theta. We plug r in, so it's 3 plus 2 cosine theta times sine theta. And we can plot this into your calculator. Find the derivative at that point, give us 0.5. So because dy over dt is positive, that means y is increasing with respect to t. So what we can tell about the particle, so the particle is moving away from x-axis. Y is increasing. Let's have a look at the rubrics. 1 point for this part, 1 point for the limit, and 1 point for the integrand, and 1 point for the final answer. dr over d theta here, 1 point, the value, negative, explanation, 1 point, expression, 1 point, 1 point here, and 1 point